Let's take a look at a couple more examples where we're going to be solving for x with rational functions. In this example, we have some rational functions on either side of the equal sign, so I'm going to choose to move all of them over to the left-hand side first. And then from here we want to combine all of our rational functions into one overall fraction. So let's factor our first rational expression to see what factors are in the denominator. X squared minus 9 is a difference of squares, so we get x plus 3, x minus 3 in the denominator of our first rational expression. Let's take a look at our second rational expression, 1 over x plus 3. To create our common denominator, we need to multiply this rational expression by x minus 3. Let's go ahead and add that factor in. And our last rational expression is missing the factor x plus 3, so let's add that in. And that's going to give us this expression here. Let's simplify the numerator. We're going to get 2 minus x plus 3 minus 3x minus 9 inside of our numerator. And simplifying this a little bit, we're going to get minus 4x minus 4. So now we have a single fraction that's equivalent to 0. This means that our numerator must be equal to 0, or negative 4x minus 4 is equal to 0. We can add 4 to both sides. This is going to give us negative 4x is equal to 4. And then dividing both sides by negative 4 gives us a final value of x is equal to negative 1. And let's just quickly double check our final solution of negative 1 to make sure that it's a valid solution. The first thing to notice is that if we make the substitution of negative 1 into our denominators, we're not going to get anything that's undefined, so that's great. If we substitute into our first rational expression that's on the left-hand side of our equal sign, we're going to get 2 over negative 1 squared minus 9, or 1 minus 9, that's negative 8. So the left-hand side is going to simplify to a fraction of negative 1 over 4. So let's double check that the right-hand side is going to give us negative 1 over 4 as well. Making a substitution of negative 1 into the right-hand side, we'll get 1 over negative 1 plus 3, that's 1 half. And then 3 over negative 1 minus 3, that's 3 over negative 4. And what we can do here is find a common denominator of 4. And we get 2 minus 3 over 4 for negative 1 over 4. So yes, our solution is a valid solution to the original equation. Let's take a look at another challenging example. Let's try to solve for x in the following equation. First, let's move all of our fractions over to the left-hand side, so our right-hand side is equivalent to 0. I'm also going to factor all of the denominators in this step as well. Our first denominator is going to factor into x plus 4, x minus 3. Our second denominator factors into x minus 5, x plus 4. And remember, we're bringing this fraction over to the left-hand side, so I'm going to change the sign in front of the fraction, and I've factored the denominator into x minus 3, x minus 5. From here, we want to try to find the lowest common denominator. It looks like our first rational expression is missing the factor x minus 5, so I'm going to add that into the first rational expression. Our second rational expression is missing the factor x minus 3, so let's add that into the second one. And our third rational expression is missing this factor of x plus 4, so let's add that into our last one. Now that we have a common denominator for all of our fractions, let's simplify this into one overall fraction that's equal to 0. The numerator of our new fraction should be 5x minus 25 plus 4x minus 12 minus, in brackets, 3x plus 12. In this step here, I've just removed the brackets to get negative 3x minus 12, And we can go ahead and clean up the numerator just a little bit by collecting like terms. We should have 9 minus 3 for 6x. We have negative 25 minus 24 more for negative 49. So we have an overall fraction that's equal to 0. This means our numerator, 6x minus 49, must be equal to 0. We can add 49 to both sides to get 6x is equal to 49, and dividing both sides by 6 gives us a final result of 49 over 6. In this case, making the substitution back into our original equation is going to be a little bit messy, so I'm not going to do that for you, but you should specifically check that this particular value of x that you get doesn't cause division by 0 in the original equation. If we substitute this value into any of the factors in the denominators, we're not going to get division by 0. So we're going to accept this as a valid solution to our original equation.